Yeah, hi guys. I'm just gonna make a really quick recap video about chapter 1 for anyone that's still not sure on how to study for it or what to do, since I didn't post quizzes and notes and whatever because I didn't study them personally. But I'm gonna make a quick chapter. So we know that equilibrium is the state, equilibrium only exists in closed systems. So if you do not have a closed system, know that you do not have equilibrium, because you can't observe constant properties as long as if you have an open system. So it has to be closed system. Like, and we know that this entire chapter, practically what's the most important part that's gonna come in our exams, is asking us about LCP, which is Le Chatelier's principle, and how we counteract it. So I'm just gonna do a quick explanation about that. So LCP is made out of 4 different rules, which I'm gonna say verbally because if I'm gonna write them, I'm gonna take like a year. Rule 1 is the impulse change. Like, these are the steps you have to write. Your impulse change is the change that happened. How will you counteract it? Or like how has it changed on the system? And then how will the system counteract it? And then you're gonna just put the concentrations of the things they're asking you for. So let's see, you have reactant 1 plus reactant 2, and it's at equilibrium with product, the product 1. Oh, yeah, equilibrium, sorry. Product 1. Let's say you decreased concentration of this on this side. If you decreased it on the reactant side, the system, what is it gonna do? Like I told you before, always count it as if it was a competition, as if you have team 1 and team 2. And since if you're gonna, the teams, when they have to compete, they have to be equal. So let's say this team has less people, but maybe it has a advantage over this team with more people. So let's see now, how are we gonna give advantages to the team with less things? So if you decrease the concentration on the reactant side, the system, the equilibrium, is gonna go this towards this side and go back and increase the concentration here. But if you decreased concentration on product side, if you decreased it here, it's gonna go towards this side and increase its concentration, because it's trying to give the team with less advantages an advantage. So in the case of concentration, if you decreased it on this side, know that it needs to go back to this side to increase it again. If you decreased it on this side, it has to go back to this side to increase it again. Now, after concentrations, we're gonna talk about pressure. Now, let's say you have pressure is only affected by gaseous moles, by G moles, nothing else. So, G moles only. When you increase pressure, you look for less gaseous moles, so less G moles. But when you decrease pressure, you're gonna look for the more gaseous moles. That's it. Like, honestly, that's it for pressure. Now our last point, which is temperature. Temperature might be the hardest one for everyone. So we're gonna start with, if you have, let's say, the same thing but R1 plus R2 is at equilibrium with the products, and let's say it's, here you have your energy. I'm gonna write it as E. So if this side has the energy, you know that this side is exo. Sorry, that's supposed to be an E. You know that this side is exo. And if this side's exo and this one is going back, this one must be endo. But if we have our energy, so this is in this case, and let's draw another case where we have it as an endothermic as your forward reaction. So R1 plus R2 plus energy will give you is at equilibrium with product 1. Now this here is our endo and the other one would be exo. You always have to point out your endo and exo sides before starting to solve anything at all. That's the first thing you have to do. So if this is our exo. Now let's say you increase temperature in each of these cases. If you increase temperature, increasing temperature always favors exo. Let me write it here. Increasing T will go towards endo. Sorry, I said exo now, it's endo. Will always favor endo. And decreasing temperature will always favor exo. So decreasing temperature will favor exo. Always. Exo side, by the way, it doesn't matter. Like, see? So let's say you increase the temperature here. In this reaction, if you increase the temperature, it's gonna go backwards. Why? Because our endo side is the backward side. Like, see, if you increase T, it's gonna go backwards. But if you decrease T, it's gonna go towards your exo side. Which one's your exo side? So decrease T, it's gonna go forward. In this case, if you increase temperature, it's gonna go towards your endo side, which here it's forward. And if you decrease temperature, it's gonna go towards your exo side, where here it's backwards. And these are for, so this is when we have concentration changed, here is when you have pressure changed, and here's when you have temperature changed. Quick recap, concentration, it's always gonna give the advantage to the side with the less concentration, or the thing where you decrease the concentration, it's gonna go towards it. But if you increase concentration in products, I forgot to mention, but if you increase concentration in products, it's gonna go give that side the advantage because here you increased it in something. If you increase the concentration in the reactants, likewise, it's gonna give the other side the advantage, so it's gonna go this way. The system is gonna favor these ways, just memorize it. For pressure, it's obvious, higher pressure, less gaseous moles, lower pressure, higher gaseous moles. And now I just need to add like 2 more points and we're gonna be done. In adding a catalyst, when you add a catalyst, adding a catalyst is not gonna change, it's not gonna favor anyone. No favoring, it's not gonna favor a product or reactant, no favoring. And so it has no favoring over any side, but it's just gonna increase rate without doing anything else. So when you see a catalyst, it will have no effect according to LCP. And if you add a noble gas, which is a gas that's unreactive, it's gonna have no change whatsoever on anything. So it's no change, just directly. You see noble gas, no change. And I forgot to add a little point for for pressure, for the pressure up here. If you have equal number of gaseous moles, so if you have equal G moles, no change at all. No change. It's not gonna favor anyone since they have equal gaseous moles. And make sure it's gas moles. Like when you're looking at the state symbol for pressure, make sure you're actually looking at the gas. Because sometimes they might stick in an aqueous or a liquid or a solid, Always make sure you're counting only the subscripts of gases. And that's just a quick recap for chapter 1 for anyone wondering. If you know these steps and you know everything here of LCP, you should be good for the exam, and I hope everyone passes. And yeah, we're done for that. Bye.